Hey Aaron, how's it going?
Hey Matt, good. How are you?
Not too bad. Hopefully the audio is fine for everyone. It sounds a little bit quiet on my end, but that might just be because I've got my volume down.
You
So
sound good
you
here.
might
It's
have
fine.
noticed Paul is away. He is helping out on an event today. So as you might have noticed in my little overlay from beforehand, Aaron is joining us as a special guest. We've had him on a couple of times. But yeah, my name's Matthew Coles. For anyone that hasn't watched our stream before, I'm a principal technical account manager working at AWS based in Melbourne. I'm not in a shed. I'm in a cabin in my backyard. So it's close enough. And Aaron, do you want to introduce yourself a little bit?
Thanks, Matt. I'm Aaron Semf. I'm a senior partner solutions architect in the global systems integration team, and I'm just filling in for Paul today, as he's off on some important business. And I'm in my home office. I know on previous episodes I have been in my workshop, but it's a bit of a mess today, so sticking to the home office.
No, that's okay. And you've probably got better internet over there anyway. So today we have a couple of things in the Amplify and Appsync realm that we'll take a look into. So we'll talk about it after the What's News. We might have just a very quick update on what's happened in the last week in AWS land, features that we're excited about. And so I might just quickly jump over to that and get my screen sharing up for everyone to see. Give me 2 seconds. Here we go. We're in business. So the first thing that's come out is IoT Device Defender now supports detect alarm verification states. So this is cool for IT projects. You can have an alarm based on detected behavior anomalies as well. So this is going to be really cool for like remote devices and you wanting to know what state they're in. I haven't played with the feature just yet. It's only been out in the last week, but this might be something that we do in one of our later episodes when we start to experiment with Raspberry Pi and Greengrass. There's a special project that we've got lined up for Christmas. So Paul's been building that out in the background. I need to lean in and do a little bit of Python to kind of help support over the coming weeks and some soldering. But yeah, this is a pretty cool feature to have. And I can see that it doesn't have the regions yet. But anything you like to add to that, Aaron, I guess?
Yeah, I think like this is an important one, especially for with the recent releases around location service and stuff. So utilizing, I think what would be a great idea, like Matt was saying, we could have a look at it with the Raspberry Pis, but utilizing this feature to understand whether the actual device is being tampered with. So for fleet management and stuff, if you're sending location updates through IoT, having your physical devices in vehicles and stuff like that, allowing you to do device checks on security, like whether it's been tampered with both physically or virtually if somebody's trying to hack it. I think this is a really great feature that I'll be looking forward to actually personally getting involved and testing out.
It sounds very similar to like mobile device management, which I spent some time doing in a previous life. So you want to know what the state of the mobile devices that are connected to your corporate network are. So mobile device management
Yep.
comes in, and you've got alarms that trip to say this hasn't had a software update in a while, it hasn't been turned on for a while, or this device is doing something irregular and that's connecting into the proxy that we've got into our intranet, etc. So yeah, no, this is a pretty cool one. The next one is Quicksite Queue is now generally available. This is something that I have yet to play with as well, but it seems to be an NLP, natural language capability that it allows business users to ask questions about the data. So if you remember in the Quicksite views, you'd usually have like a dashboard and a bunch of visualizations of data that you've got. You might have a pie chart, you might have a couple of different types of charts, and it shows you like where everything sits based on the live data underneath that you've plugged in. This sounds like we're getting to almost like a Alexa type experience, and it's like tell me a trend to do with the data that I've built in my dashboard. Like maybe even on the prediction side, predict what sales are going to be next month. So this is kind of cool. I know that we're really invested in building out Quicksite, and like this year seems like there's been so much that's been added into Quicksite. I think we're going to see more and more of this stuff in the future, right? Because it helps people use data. Anything to add to that one, Aaron, I guess?
Yeah, this is a great addition to Quicksite. So I just call out like the likes of Kendra and how Kendra Elasticsearch extended the Elasticsearch capabilities with adding natural language recognition as well. So I've done a lot with Kendra, and actually the differences between, searching on, having to refine your search parameters down to get the right results from an index is amazing when you can just start asking questions, and then it actually relies on the natural language algorithms to recognize what you're asking and finds a better result from your index. Having this added to Quicksite, man, I can just imagine many different solutions where we're tying together the visualization of, of the data, but also wanting to derive additional insights by asking questions like FAQs on the data that you're actually visualizing. This is a massive big step forward.
Yeah, it's very futuristic as well, right? Like, just tell me the insight around this. I feel like I'm in Star Trek or something, right?
Yeah,
being able to
I'm
make those
seeing
calls.
that.
Yeah.
What's the movie with Tom Cruise where he's got the dashboard in front of him and he's moving stuff
Minority
around to
Report.
get Minority. I'm seeing Minority Report with Quicksite Queue. What's the underlying resolver for this data? Where does this data come from?
Yeah, no. So this is really, really cool, and I do actually think that I have to have a play around with it, and I know both yourself and myself love NLP, NLU. Like, we've done a lot in terms of like not the science side on how it works, but used it in projects that we've built, right? Yeah. So, and I can see Monkey Moo's kind of shared NLP. Yeah, so natural language processing. Just for anyone that's watching that's not aware of what that is, and let us know in the chat if you've done any projects in that space as well. I'd be interested. I feel like we should have like a particular segment for some of the cool projects that have prototyped in that space eventually.
Yeah.
Now, the next one is one that's close to my heart, and I think it's not really that commonly known. But, Device Farm started off as something that you have for testing your native mobile applications. So you'd be building like your iOS or your Android application, and you want to test how it works, if the screen sizes come across right, through multiple devices, whether like some of the variations of the platform in the OS version like don't cause weird artifacts or issues, like where maps doesn't render in one, or the tracking on the map breaks, like in particular I've seen a lot of the times. So Device Farm really started as like testing real physical devices and having like a large collection of them that you could quickly run your application across and then report errors on. Over the last year and a half, I think it is roughly, Device Farm's also kind of expanded out into browser testing, which is really cool. So it's got support for Chrome, it's got support for Firefox, it's got support for Internet Explorer. We've moved into Edge. These are desktop browsers that you can test as well. So you can actually, if you're building a web application now, you can run like Selenium tests over your web application to make sure that it's going to act consistently in different browsers, different resolutions of different browsers as well. So this is really, really good, like breaking into the web application side and helping make sure that when you release a website, it's going to act quite consistently. I know we've gotten a lot better over the last like 20 years in this space. I remember when I started and we were supporting like very old school browsers that like had half the functionality of other browsers, and you ended up having like weird JavaScript hacks to kind of work around them. I feel like things work more consistently today, but even yesterday I saw a particular thing where iOS 15 came out, and a framework that isn't JavaScript but produces like web-based code didn't render at all. It just came up as a white screen. And so, like browser testing still, even though we've got like, I guess more common browsers with more commonly shared like features across each of them, there's still these times where something doesn't work quite right, like the authentication's not working or something's not rendering on the screen. So browser testing is still very, very important today, even though it's less of a headache than it used to be. Do you want to talk about some of your experiences in that area?
Yeah,
Aaron?
like I think browser testing is very important, especially like, again, close to my heart as well. Matt and I both work very much around the mobile and development space. The actual WebView style application. So actually developing hybrid apps is there's a big market for developing a hybrid app that works both in your mobile and on the web. Obviously, there's different angles to approach it. Yeah, like doing the native hybrid app. So you're developing web code that runs natively. But the WebView style apps, there are a lot of apps out there. A lot of businesses actually develop their websites or their web apps to run on mobile as a web view as well, and then utilize some of the JavaScript framework to integrate with the APIs through the browser for the mobile to get additional capabilities. Being able to actually do that testing in one, so now you can test across your mobiles, you can test across your desktop browsers for the same app. I think this is, like I've obviously it's been progressive over the last year, but seeing looking at the actual market share for Edge, now the new one, Safari, Chrome, all being the top share for browsers being used predominantly in mobile and desktop. Especially in, I'm just looking at desktop at the moment. Like Edge still is 8.84% market share of browsers. So this is still a big portion of people who are using or developing for, and especially because I think it comes. Correct me if I'm wrong, Matt, but I'm pretty sure Edge is now the default browser for Windows. It used to be IE, but it's now Edge. I could be wrong.
It's now Edge. Yep.
Because I'm seeing that IE itself is down to 1.43%, which to me would say, yep, Edge is now the default for Windows. So just on that alone, you'd need to be testing for, if you're not accounting for 8.84% of your market when you're developing apps, that's too big of a chunk to not account for. So it's an important step.
Yeah, and I know, like, in terms of like pre-baked browsers as well, like there's issues that happen with Safari, also that need to be planned for these days, because that's kind of the one that's missing some of the newer features that like like some of the browsers like Firefox and Chrome have adopted pretty fast. I can see Monkey talked about IE10. So back in the day for me, it was IE6, right? Because I was doing some consulting for government. And government, we basically had like, I think 5% of the code base that we had was like for the web application front ends.
Yeah,
was like unique to work in IE6, right? Because IE8 would support what we were doing, but like a lot of people were still using IE6 back in the day, and government wanted to make sure that the application could be used for across the board by anyone.
it's not just government too. I remember a similar situation updating some systems for a medical organization. A lot of their apps, they were built for the browser, and it was all IE6, and it was specific to IE6. So it wouldn't run properly on, Netscape back then. It wouldn't run properly on the other competing browsers. It only ran properly in IE6, and there's still a lot of legacy apps out there that will only run on older browsers.
Yeah, that's exactly right. So yeah, that's it in terms of like what's new this week. I just wanted to highlight a couple of things at the moment. I know we're on quarter past, and I'm eager to show off like some of the projects that we've had in the Amplify and the Appsync space, between Aaron and myself. So what I might do is I might start with my one, and I'll make sure to give ample time to Aaron as well, like with what he's got. But one of the things that, like emerging framework wise, I like to play with the new toys. I work in AWS, so I can play with a lot of the new toys. And, like Quicksite's one that I've got on the back burner here, and there's like a million others. But over the last week, I had time to work with Next.js, and I had a bit of fun with it. I wanted to learn how hybrid rendering would work between like server side and client side. Because usually, I guess in the past, it's been quite distinctive, right? Like we used to build server-side rendered apps way back in the day, like 5 years ago, maybe. It's not really that long ago, to us at least. I'm getting old. But like server-side apps, like the whole point of them was that you'd get really, really good SEO. Like search engines didn't have to render the app and then interpret it to kind of create the metadata that was needed to make it indexable. That's kind of evolved now, so it's like slightly less important. SEO is done client side a lot of the time, but the other benefit of server-side rendered apps was mobile devices were brand new, and a lot of people's computers were quite underpowered, and so having like a lot of the heavy lifting and internet connectivity was like poorer, right? Like people had like, still in Australia, we have a lot of like places, poor internet connectivity. But like back in the day, like nearly everyone like suffered from that like universally. And so server-side rendered apps, the idea was it could all be pre-rendered on the server, sent as a package of just like HTML, straight down the to the end client, and then the end client doesn't have to spend any of its compute on that, and the network bandwidth like can easily consume like what's been sent down the line. And so that's kind of where server-side rendering came into the equation. And from that we went client-side. And the reason why we went client-side is because we could have these single-page applications that would like download a JavaScript payload, like render it all, compile it all on the device. And from a user point of view, they don't have page changes, and it's a really nice, smooth experience, and it was similar to like native apps, to some point. So what I'll do is I'll get my screen share off, and I'll just show you like what I've done. So Next.js kind of like tries to meet in the middle. So it allows for the benefits of server-side rendering when you choose to do it, and then it also allows you the benefits of like client-side rendering when you choose to do it as well. So I've built this app, and we're going to put it through, connected into Amplify, and we're going to roll it out on the cloud today.
Have you noticed much of a difference in the speed for getting the data out for both the client and the server-side rendering?
Not too much, but like the problem is I've got the latest devices like a lot of the time, and my internet's pretty fast, so I don't see the benefits. But there's ways that you can tell like something's happening, so I'll show that for everyone in a second. Now, basically, one of the other things that's quite unique to Next.js is that every page you create in the pages folder is basically a route. So this is what I've learned over the last week. And I'm going to bring up my screen now. Here we go. I just realized I didn't have it up. So I've got this pages folder, and I can have API and then like a hello world, which was my initial test in this. So it's fairly basic. But I've got this index.js. So whenever I actually go to localhost and I'm running this application, like this particular view is going to like load up, and all the routes are just like based on each of the files in this directory, which is kind of different and cool.
That's very cool compared to like React Router, having to install the router in to do your hash routing. Like just having a file to separate your routes, that takes some of the heavy loading out just for development.
Yeah, and there's still times where you want to do more of the routes as well. So, and I can see Shree's asking about your NASA hoodie. So, did you want to cover the background on that? I've seen you wear it a couple of times, Aaron.
Well, it depends on the time and the occasion. Before at AWS, the organization that I worked for was a contractor for NASA, but or most recently, it's more in support of Blue Origin and the work that we're doing with NASA.
Nice. No, that's cool. Yeah, I weirdly enough, there's like bits of NASA in Australia as well, if I remember correctly, because I've had some colleagues that have been software developers that have worked as contractors for them as well, like in the past. So that's pretty neat. But so I've got this index.js. I've got this about file, which is just basically some text. I've got this location deep dive, because within my index.js, I'm basically like showing the recent coffee shops that I've been able to theoretically visit. And I've mapped each of those out, and I'm just giving them a title. But what I do is I actually, like, when I click into them, I have all the information that I've got about the coffee shop shown. I've got this navigation bar to make it easy to click between each of the routes. And so all that I've done is I've just used the Next.js link library, and I've put home and about in there to make it easily navigatable. So it's a fairly simple app that I've made. But the one thing that's interesting about this as well, in terms of my learning, is that you can use get initial props. And if you use get initial props, what this is doing is server-side rendering on the data to create the view for the props that need to go in and be referenced within the web application. So this is pretty different to standard React. And you can see, like, all that I'm doing with the props is I just basically have this JSON file that is like a list of all my coffee locations. So what that looks like is, if I share my other screen, here we go. Hopefully it's popped up for everyone. Yep. So what that actually looks like in reality, right, is a homepage. I've got the about page that I can route back to. And I've got the list of things that are created in my JSON feed, and then basically just dynamically displaying like each of these locations. And the way that I'm picking up like which locations what is I'm looking at the ID in that JSON file of the location. So that's determining like what should be shown, and I put that as part of like the query in the header here. So fairly simple site. But what I wanted to do today is, like, I've been playing around with Next.js on and off for like half a year. And one of the things that Amplify has supported recently is the ability to basically send this up into the cloud to be hosted. So what I'll do is I will go back to the code and I'll show you what that looks like. I would share my whole monitor, but it's a bit of a widescreen, so it comes across weirdly in the streams. So we're just going to have to do some flicking in and out. So apologies for that. But over here, back to my application, what I can do is I could do a new terminal if I wanted. I could basically do like an Amplify init, hook up Amplify for my project.
Is it for the server-side rendering? I know I've had requests for doing server-side rendering, obviously with React apps in Amplify. The static hosting obviously doesn't work for server-side rendering because it doesn't allow the routing. Does this allow us to go through the tool chain now, like through the CLI, and set up non-static routing? Awesome.
Yeah, that's right. So that works in most situations. I think there's still a couple of things that I've seen on GitHub where people have had problems. Next images as well, like if you're using certain things, can be a little bit problematic at the moment, but they're kind of working on fixes for both. And I can see someone ask why bother with this versus standard React, and I think it's like server-side rendering. If you want to build a web application, have APIs into your backend, et cetera, like this allows you to do both, right? Because it's kind of combining Express.js with React. It does have separation on what's done server-side versus what's done client-side. So it just allows you to basically build your code out in one space. And it allows you to have some like nice tricks, like in terms of like being able to mix and match on the fly, right? Like in terms of like what you want in your app, in terms of where the rendering should take place. So yeah, I love React. So I'm always going to work with React, but this was just something that was fun to experiment in. So what I've done is I'm just going to do an Amplify net. Go ahead, Aaron.
Can I just ask? Yeah, I just on top of that question, I actually like that question, but from a development specific perspective, not specific to React, Amplify, but with React, I know a lot of the time I use React to develop like micro front ends. So I'll develop components that are embedded into other applications that aren't using React. So it could just be some other framework, and then you're embedding components that it can manage separately. I can see I've not done anything with React.js, so I'm not sure how componentized it can be in terms of when you're just using React. How, like, for me, this looks like a better way of doing a single page application. So if you're building a spa, Next.js makes it so much, by the looks of it, makes it so much easier than, using React. To that question, that was a great question. But maybe you can tell me, Matt, whether is React capable of getting as modular, so developing micro front end components for other apps and the like, as React is?
Well, I think micro front ends is like an interesting point of view, right? Like a lot of people are kind of, and I guess there's a couple of Australian companies that have blogged about it recently and have been experimenting about it as well. So you can read some of their success online. But like micro front end seems to be like a big trend happening in the React space at the moment. For those that don't know what it is, it's basically like, your front ends could be labeled as a monolith. I kind of disagree with that terminology, but that's what it is within the micro front end realm. And the micro front ends are really like trying to be able to break up like pieces of your application to be like manageable by small teams or singular individuals. Yay, more modules. And so the idea is someone can own the life cycle of a particular piece of code. And this is really important, like when organizations have very, very large web applications. They want to be able to break these out and have it more manageable by teams. And they want deployment to be faster. They want deployment to have less of a blast radius if something goes wrong, like it doesn't bring down the whole website as well. So there's this trend of like basically embedding like mini React apps within a major React app, and like it's still being explored because a lot of people are having problems with like, you know, library versioning like of the mini app versus the main app, and like, you know, the dependencies have mix and match problems. And so like people are using like web components and in particular to kind of like break things out so they can kind of have their own little realm for that particular application that's been built. Like I guess React or Next, I don't think it really matters which one you choose if you're going to explore micro front ends, right? Because at the end of the day, like you're basically going to use web components or create specific components for like these mini pieces of apps that you're breaking up. And I don't think one's going to handle it like more gracefully than another. And to be honest, like, you know, like I like Next, but, you know, it comes to the point where I'm like, you know, like you could probably build something faster in Django or, you know, PHP.
Yeah.
Like people can throw stuff at me now if you want a server-side rendered app, and it's probably going to be like more clear. Like even though, yeah, exactly. Even though you've got the distinction of like, this is our front end and this is like the back end for that.
See,
like it's
I will always favor
in the traditional frameworks than like mix and matching here, right? Like you have to know that get initial props is like server side rendered. You've got to know like that this is partly server side rendered. Like you're handling auth tokens, like you know, like you've got to be more cognizant that like because everything sits together, even though it is defined in the framework's documentation, like you've got to be cognizant of all the time of not exposing the wrong information client side. So that's kind of like a little bit of the danger side.
First of all, PHP boo. I will always favor
it's got a more
even for server side.
On it, yeah, I get you.
No, .NET, C#.NET application with Razor any day over a PHP application. But to that, what I was going to say is I've actually seen successful deployments of micro front-end applications where .NET, so that the C#.NET application services the actual the monolith, so the actual component that binds everything together. But then the front-end frameworks, I've seen actually a combination of both Angular and React being used for different components. So there are some sort of what they would call embedded applications was the Angular side of things. So like micro applications running inside the larger web app. And then the actual React used for like we used to do with web components, just the smaller components for small utilities working around a React app, all embedded in a .NET application. I'm not saying that's the right way to do it, but I've seen it work, and it's very interesting mix of technologies, both server-side and client-side rendering.
Yeah, that's right. And I guess like what we try and do with the Amplify point of view is we try and support all things. So like if you like Next, you know, you've got support for that. If you like React, there's support for that. If you're doing anything in the JavaScript world or native code, you've got the ability to use Amplify to deliver for those situations. You know, if you're building something more traditionally in like PHP or .NET, like we've got the appropriate SDKs to easily integrate with other AWS resources there. And, you know, documentation on like where and how to host it as well. Like if you want it in containers or you want it in, you know, directly on an EC2 or you want in Lightsail or Beanstalk, like you've got lots of different options based on what you want to do. So AWS is really all about choice at the end of the day. And that's kind of why I'm kind of open to everything at the end of the day. And I like to just experiment and learn. And that's kind of like what I've been doing here with Next.js over the last couple of weeks. So what I'm going to do...
Mookie Monkey's comment, have a JS framework that combines all JS frameworks.
Isn't that just... I'm going to be nice. Yeah, my node module sometimes like goes way out of hand, right? Like we're talking about like gigabytes of data sitting there. Like I feel like I have downloaded the web worth of frameworks. Yeah. So what I've done is I've done an Amplify ad hosting, and I've chosen to do deployment through the Amplify console. And that's because I actually want to just hook up the whole project that I've got in GitHub and be able to have that build server side. So what I'm going to do is I'm going to stop sharing my screen, and I'm going to move across to the Amplify console that I've got open in the background here. Yep, hopefully that appears for everyone any second. There we go, we're in business. And so what I'm going to do is I'm actually going to go host a web application. I'm going to connect into a particular branch. I chose GitHub, of course, and I'm just going to go to my Next.js demo that I had open beforehand. I'm going to go to my Baysite branch, and I'm going to go ahead and configure Amplify to effectively host and manage this. So every time I push to that particular branch, it's going to build a version of my application. So that's effectively what I'm trying to achieve. And what I've got is I can have like a YAML file that tells Amplify more about what I'm building. So that might tell it that we're using Next and that like these are the commands to run a build. And so we can specify things that are unique for the framework in there. So I've kept that generic. I actually haven't changed anything. Like this is all what was auto-detected by Amplify in the first place and what it would be building if I was just to go click through the console. But I decided to add this particular piece as a YAML file into my application in case I wanted to do like build commands, testing, etc. I can kind of expand the commands that I might run in each of those phases to do different things. So it might be eventually. You can see that it picked up that this is a server-side rendered app, Next.js. And what I can do is I can just go save and deploy, right? And that's all it takes to basically spin this up in the cloud and have it hosted. So it might take a few minutes to build. So I'm not going to bore everyone with the build process. We'll come and look at like what was done at the very end of it. But you can see like I've got this URL. When the app appears, it should be blank for me now. So welcome. Yeah, once the first deployment's done, I should have my app here hosted. If I wanted to add my own domain, I could just go to domain management and I could go add domain. And if I brought something in Route 53, I could then choose it from the drop-down and configure those domains. I can get a preview of the builds. I could split this up with CI/CD and I could have like different branches do different things. So one branch might be delivered into IOT, one branch might be delivered into my development environment. I might password protect both of those if I've got live URLs on the internet. So I can set up all of that with Amplify. And then the production one, anytime something hits the production branch, I can have it like roll out like the CloudFront hosted version that's like right across the internet if I wanted to, and host it on the main URL. So that's kind of like a little bit on this side. The build will take some time. So the build process itself might take 5 or 10 minutes to do. So we'll leave it as is. But the other side of the equation as well is if I wanted to break away from that JSON file, so if I wanted to go back into my code and put that up on the screen, like, because I really don't like having like this JSON file here. Like if I was to move away from this and then like slowly make it more dynamic, and this is where we'll come and go into what Aaron's got to talk about today. What I could simply do is I could go like Amplify add API, right? And what that's going to let me do in the console here is effectively create either a GraphQL based API, like if I wanted to use Appsync, or a REST based one that's using API Gateway and Lambda. So I've got this pre-made like Lambda that basically does exactly the same thing with the JSON, but it pushes it out into this JSON object and then renders it through the Lambda, and then it's got cores set up so I don't have any problems. So I could actually like basically just go REST, leave a generic name for the API, call it coffee. And Amplify uses CloudFront, by the way. And you could use Lightsail. You could use Amplify. Amplify is serverless. So it's going to put things in S3, CloudFront. It's going to generate lambdas, lambda at the edge. It's going to use whatever it can on the serverless side. You can kind of eject into like more traditional systems as well. Like if you wanted to use a standard relational database, which is what Aaron might talk about in a second, or you wanted to have a couple of microservices, you can containerize that and have it hosted as well. You can break away to other AWS services that aren't within the list of libraries that are compatible with Lambda into basically anything within the 200 or so services in AWS land. But like today, all that I'm going to do is I'm just going to create like a Next.js Lambda. And I'm not going to configure anything too advanced. And I am going to edit it now. And not restrict access. And basically, like now I've got this Lambda, right? And I can basically, the pre-written Lambda that I've got, that's quite simple, I can just like replace here. And in the Amplify backend folder, like the Lambda sits here as a function, and each of those functions will be based on the name that I gave each of them. And I basically just save this file at this index.js file. And then if I wanted to do a build, I could just do an Amplify push, right? And what that's going to do is that's going to commission that Lambda in the cloud. It's going to put API gateway at the front of it. And it's going to then return a URL that I can basically call in my application instead of pointing to the JSON, which is pretty neat. So you can see these are the two resources that it's going to create. Everything's generated as Cloudformation. So when I actually go continue, I'm going to see a new folder appear, which is going to be called Current Cloud Backend. And that's going to be referencing everything that's been created as execs within the Cloudformation, which might take a few minutes. And I am cognizant of time because I'm keen for everyone to see what you've got as well. So what I might do is let's flick back at the end, Aaron, when my web application's been hosted and my Lambda is set up, I can show everyone what that looks like.
Cool. Yeah, cool. I don't want to lose out on that. I'm really conscious. I personally really want to see the end result because I'm a big fan of, like, obviously mobile and web, but server side versus client side. There's a lot of requests that I get come through a lot around doing both in different situations. Very keen to see how Next.js works. I haven't had a chance to play with it. What's if you're called? Does that create a separate service, and can you see it? Do you want to answer that one, Matt?
Yeah, so I'll show that at the very end, but what it does is it actually builds that API gateway out, that Lambda in the account. It's using CloudFormation. Actually, I can do it. I can show quickly now, right? Like it's not too hard to quickly bring it up. Let me pick my browser. So that build's still happening, like for the hosting, but like effectively, if I go into CloudFormation now, I've got this stack that's been created. And this stack is going to be, like here. So this is the root stack. The resources are getting created here. But you can see that it's created like a bucket. It's created this API. And it's done all this through CloudFormation. So effectively, like I can replicate this across any other account that I might want, or deploy in another region, this Amplify application really quickly. And then if I go into the API gateway side of the equation, like it's all there and transparent. The good thing is, as a developer, I don't have to think that much about it, like to get started. But as I learn more about the service and I want to do more customized things, I can use the escape hatches and like know how to work with these services in particular. Like I might actually like directly code CloudFormation to create some assets, or I might use the Cloud Development Kit to do that as well. But in here, I've got my API gateway defined as coffee as beforehand. If that's deployed, I might get a test back. If I do a get, right, it might not have deployed just yet. Let's just test it. Yeah, it's actually deployed already. So you can see it's returning that JSON object with a list of the locations. And if I went ID equals like 2, I'd expect to get St. Alfred's back only in that get, because this adds a query string to the end of the URL for the Lambda. And there we go. So like now I've got this Lambda up in the cloud that I can call. I've got an endpoint that's accessible. It would have put that back in the console for me as well. So I'll know what to integrate with my app. And then like on the other side of it as well, like what does that Lambda look like? Actually, don't see the Lambda just yet. That's weird.
It'll come.
Yeah, it's probably still. Oh, here we go. 2 minutes ago. So this will be it. So you can see it's attached to that API gateway, and then you can see that same code in the index.js file has just been basically built in Lambda, which is nice. So did it follow your scheme about around being a feature, or is it global? I'm not too sure on that particular question.
I think what you mean by that, like it is in the scheme, like it is in the feature in so much as it's in the stack. It's in the actual Cloudformation stack, but it's accessible globally. So anywhere in that region, you can access that Lambda. You can have that's a great sort of segue to why I wanted Matt to explain that, because as an integration specialist, I actually work a lot more with a lot of the services inside AWS that aren't set up through Amplify, but a lot of the requests that I fulfill start with Amplify. So the customer will be developing an app that they've developed through the Amplify toolchain. They've got their assets up and running. They got their app up and running, and they're like, oh, but I've also got other stuff in AWS that I need to integrate with. And that's where, so exactly what Matt was doing, creating that Lambda in the Amplify app. So while it's managed through Amplify, it's actually still in the Cloudformation stack. So that you can pull it up, you can update it and everything through the Amplify console or the CLI. But I can now access that to either modify it in the console if I wanted to sort of go and do it from a different point of view, or I can do my modification of the Lambda function in my Amplify app management, deploy it, and then have that connect to other resources in AWS. So a big one that I get, and I think I talked about this early on in one of the earlier devs in the Shed episode when we were talking about the location services. One that I often get is integrating with an existing RDS database. So SQL, Postgres, different RDS instances in AWS, integrating with the application instead of, like you saw before, Matt was using add API and select GraphQL. That actually creates Appsync, and then it creates a DynamoDB table to back the actual GraphQL schema. So you've got data persistence through DynamoDB, you've got your GraphQL schema, and then you can start querying the API through Appsync to get that data. But a lot of customers who already have existing data have started with relational databases. So they want to integrate those relational databases, but take advantage of the Appsync, the GraphQL way of doing things. So a very recent request actually that I had was we want to be able to run GraphQL, but we want to query our Postgres database with GraphQL. So instead of, like I did in the location services episode back a while ago, and create that Lambda function and execute the Lambda function through the application, we're going one step further. I'm still creating that Lambda function, but instead of executing it through the GraphQL schema as a function, I'm actually adding that Lambda as a data source to the actual GraphQL schema. So if I share my screen.
Yeah, let me. And by the way, this is the Cloudformation that was generated. So it actually sits in the Amplify backend folder. And then what it does is it creates like the source file with each of the exports that you get back from Amplify, right? So that's my API endpoint. And if I was to do a curl to that, like input /coffee, I'd see the same list like come back that I saw in API gateway when I did my testing. But that's also the same. That's the same endpoint that I could do like a fetch with if I was to actually code this into my app. Now it is just like it's just giving me static JSON, right? But the thing that I was going to bring Aaron on for today is like Aaron's got a database that he's tied into the back end. So like something like my application, I've separated arrayed the JSON object, and now I can like build that Lambda separate to the rest of my application if I want to do changes. But eventually I'd want to think about bringing in a database of some type to basically quiz as I get more information. So that's a little bit around that. What I'll do is I'll pass to you, Aaron. I'll put your screen up. So this is Appsync, right?
So,
this isn't a REST-based API. Like, how would you describe Appsync to people?
So Appsync is a GraphQL managed service. So it actually manages the actual schema and the query engine for GraphQL. So what I mean by the query engine, it fulfills the actual schema mapping between the request map and the response map between your data sources. So this, when Matt went through and did the CLI and did, add API, GraphQL, you go through and you set up your schema. When you deploy that, when you go Amplify push, it creates this endpoint for Appsync that he just showed you in the resources. It also deploys in the schema, so it creates the schema in Appsync. And then going a step further, so I've got a Lambda function here as well. Let's just say that that's the Lambda function that you just saw Matt create through Amplify. So you can now deploy your Lambda function, deploy your Appsync. You've got an Appsync endpoint with a managed GraphQL schema. But I want to go one step further. Like in the previous episode, I was executing my Lambda function from GraphQL by inside the GraphQL schema, setting up a method to call a function. Instead of doing that, I want to go one step further and say, if we go down here, I can see inside the GraphQL, the Appsync schema, GraphQL schema manager, I can actually go down to the resolvers, and instead of setting up a method to talk to the Lambda, I'm going to add, if you click on attach, you can attach a data source. And I'm going to set up the data source as actually the Lambda itself. So instead of using the DynamoDB table, which will be the default data source when you've gone and set it up through Amplify, you come in, you remove that DynamoDB table. So instead of the request and response mapping being query these columns on the DynamoDB table and then return response, I'm now going to say I want this Lambda function to be my request, but I'm going to turn off my request and response mapping. I just want the GraphQL statement that's being sent to apps sent to my my Lambda function, and it changes it a bit. So it's not the actual GraphQL statement because it wraps it in a lot more. There's a whole information object that it sends, but I then want to take that information object, which has all the properties in that GraphQL statement, and send it through to my Lambda. So then I can actually do my querying to Postgres. So obviously, I'm using environmental variables to hand in the host name, user pass. If I was doing this for production code for security reasons, I wouldn't be handing them in as an environmental variables. I'd be using the key store, and I'd actually, in the secrets manager, I'd be storing the pass and the username and all that in the secrets manager and integrating that way. But just for proof of concept, making it work, I'm storing them as environmental variables. And in what Matt was showing you, you can set up your environmental variables in the config. So you're pushing them in. You don't have to go into the console and add them all. Here, all I'm actually querying is, just using, for this one, I'm using the Postgres JavaScript library. So it's an npm module called Postgres, so that I can actually just query Postgres using, or query PostgreSQL. I really hate that word. The database using a Postgres library. But what I'm doing is I'm actually using if I go to my handler, I'm actually using the event object that Appsync sends to the data source. That event object has an info object that has the field name, so the name of the query that I'm trying to execute. And then inside that, it has the GraphQL arguments, so the ID or any arguments that you're sending through. And the information object, again, also contains a selected items or post-select object. So that contains all of the specific items. If I go to the query console, this is what it contains. So this is the name of the function, and these are the actual select items. So when you're fulfilling a GraphQL query, you're actually posting an object saying, I want for this object, or this object in the schema, I want these properties, name and ID. You can see on the side here, I've actually, I can pull out ID. I just want to get the name of the topic, so I don't care about the ID. And I will just say, go and get the title and the topic. If I run that query again, that's going to go and get the name of all the topics. And then for all of the posts that I've made, just get the title and the topic, and that's giving me the mobile. So I can see under mobile, we've got mobile. I could just take away get topics, and just do the get post. It's the exact same thing. So all I'm doing is I'm filling out a post query to go and get data from a GraphQL schema. Now, the difference here is, and this is where at the moment, what I've done is I'm just building the actual specific queries into the Lambda to go and query. So I've got a dictionary that says, you know, if it's get topics, then we just want to go and do a GraphQL query based on the columns. So I'm pulling out all of the selected list items to get a list of the columns that I want to query, and then I'm feeding them into a select statement. And don't worry, this is actually, this SQL object is the Postgres library. So I'm not able to do a SQL injection attack here. If you were wondering, this actually is encapsulated. So it will actually go through and check that it's not executing anything it shouldn't. But all I'm doing here is I'm pulling the columns out and saying, you know, select the columns from that. Or I'm building out an object. So if we wanted to get the post object that includes comments and topics, I can then say, well, from the selected list, if it includes topics, then go through and do the same thing. Go and get the topic ID, go and get the columns, query that. The same for comments. If the object has included comments, go and query the column table on the specific post ID for the relationship and get the specific columns for the comments that have been selected in the GraphQL query. So that's the first step. Where I'm going with this is I don't want, and this is where the query to me has come in from, they don't want to have to go and develop all of the specific queries for every table. So I'll drop this, Matt, if you can drop this into the chat, this link. This is just a great article by Eduardo Rebello on exactly what I've explained to you, like setting up Appsync and AWS Lambda with an RDS, in this case Postgres. But where I'm going with this now is there are other ways of doing this. Obviously, everyone knows you can host Apollo. We don't want to be hosting Apollo. We want to be using Appsync. Equally, I could host a HTTP API, so using the API gateway, and use Postgres. Postgraph is another JavaScript library which actually allows you to, on the fly, query a Postgres database using GraphQL schema, but it doesn't allow you to break out the schema into Appsync. So what I'm doing now is I'm building out a way of being able to create the schema, as we see here, to host in Appsync, but then our Lambda would act in the same way that the Appsync execution engine does directly to a data source. We can then actually set that up to do exactly what I'm doing here. So instead of actually hard coding in the table, I can query the database schema. So if we look at the actual schema, I can see under tables, this is the RDS instance. I'm connected to the RDS instance in this account. I can actually look at the schema. I can look at the tables. I can see, is there a comments, post topic tables? I can then go and figure out, well, what are the columns of those tables before doing the query, and I can build out a Postgres library for a GraphQL query. So when the GraphQL query object comes through from Appsync, using that information object, we can then construct the query and the joins necessary for a much larger query for multiple tables, and do a single query instead of, as you can see here, I'm breaking it down into multiple queries for each different table. So that's where we're going, and that's really come from the idea that Amplify is great. It helps us get our app up and running really quick. We can develop our Appsync API. We can, set up our GraphQL schema, which makes it really quick to query much more data instead of our, RESTful-based API where we're doing a chatty-based API querying. And then instead of using our new data source, which is backed by DynamoDB, we want to start to integrate our existing data source that we already have, because this app may be a additional module on a much larger enterprise system. So you might actually have, in this case, it's a Postgres database. And for this example, I've just created some tables. It's not the customers tables. Obviously, I'm not going to show you the whole schema that we're working with, but just to show you how it works. This table could actually be the read table from a much larger database that's actually fulfilling data that's coming from other services and the like. And then this is the reporting. So you want to get that data from that reporting, that read access database, read Postgres database, and actually query out in your app and see, these are, in this example, these are field requests. So requests that are going to the field, the mobile app is actually able to see those through querying the GraphQL API, using the Lambda to then query the relational data source. So yes, the Lambda is acting similar to a SQL function. If you were to build out a traditional SQL database, you could have a, what did they call them? SQL functions. I'm more thinking, my brain's not working now. The word for when you create a function connected to a database, just more flexible. Yeah. Let's forget the term that I'm trying to look for. But yes,
my view on this as well, Aaron, is like a lot of people want to use GraphQL and Appsync to make the application developer's life easier on the app side, making a single call to get all the data back. And that might hit up like multiple APIs, right? Like multiple Lambdas that you've built in the background, accessing RDS or whatever. So it makes their life simpler from a front-end developer perspective. But the other thing that I've seen like 50% of customers start to use, like whenever I'm talking about Appsync with them, is they're almost using like Appsync as like an API manager across the organization, right?
Yeah.
Like they tie in all the data sources that they've got, and then now they've got that single endpoint that ties all their sources together for a consistent experience that can be used for like external developers if they've open sourced their APIs. It could be used to tie to their mobile and web front ends that they've built consistently. And so like I'm also seeing like this bigger picture type thing where it's like AppSync's acting as the aggregator for everything, right? Which is pretty cool. Even I've seen AppSync connect to AppSync instances, right? So you'll have 3 teams manage these 3 different AppSync instances, and then you have like an AppSync in the front of that to kind of bring it all together to be that central place again.
So that's actually, if you check out what I've just chucked up on the screen, that's actually a really common pattern. AppSync to AppSync, AppSync to Amazon API, using it essentially becomes a shim, a single query shim out to multiple data sources. This is a very common pattern that I've seen AppSync used for. The addition to what I'm doing here with the Lambda, having the Lambda instead of AppSync direct to DynamoDB, is more around utilizing Lambda to integrate with other services in AWS that aren't currently supported directly. So yes, AppSync to DynamoDB, great. AppSync to a relational database, not so much. Now you need that glue between. But where we've got this one talking to Postgres, actually this may be a domain manager. So instead of just talking to a Postgres database to do direct table querying, we might say, well, this is the domain of, to query across a Elasticsearch index. We need to query across a relational database, and I also want to go and get a physical file from S3. But I can use that Lambda to be the domain manager for querying all 3 of those and hand back a domain object with data from all 3 of those queries. And then bang, that goes back through AppSync and is handed out through the mapped GraphQL response. So absolutely, AppSync itself is the shim, or is a way of managing multiple APIs, but then again, Lambda in this instance as a data source, not specifically as a function inside the GraphQL schema, allows you to extend that without the additional having to query multiple functions by just adding it as a data source to the underlying schema.
Yeah, and I mean, it gets even cooler than that, right? Like, because you've got resolver pipelines as a feature too. So you could actually have like multiple data sources like quizzed together, and then some custom logic that works out what to do with that data as well before it's returned to the end user in AppSync too. So like, I was originally a REST-based API guy, right? Like I kind of went from SOAP to REST, and I'm like, REST is pretty good here, right? But like over the last year and a half, like GraphQL is slowly winning me, like just in the fact that, I like the single endpoint, and you can have someone manage like the connections back from AppSync. But like, I just feel like it's a really good developer experience when you've got like this organization managing AppSync for for end developers, and then the end developers can basically call this endpoint consistently, and have like that data used back in their apps, and all the manipulation can happen on the Appsync side if you need to do a lot of weird logic.
So this
probably haven't explained that the best, but yeah.
The coolest example of that is I've got an example, or I can't actually show it, so just take my word for it. But I've got an example of where a Lambda is actually servicing a serial query to an IoT device. So you've actually got a GraphQL query coming in, and the actual device out in the field, it's going through IoT Core to then communicate. So the Lambda is communicating with IoT Core, and you can actually get some device status, some information from the device, and handing it back through your mobile app device. So you're actually facilitating a mobile app to query app GraphQL to then go and get devices out in the field and understand what their status is. And then, the sky's the limit, essentially. Like, when you start to think of Lambda in this way, instead of just a function, but as a underlying attachment, or the resolver to a data source, which is your GraphQL schema, you can basically start to integrate anything, because while Appsync allows HTTP interfaces, the Lambda allows you to then extend that beyond to essentially whatever you can integrate with.
Yeah, no, that's really nice. Now, I know we've come to time, but I've got another 15 minutes, and there's no one scheduled after us if we want to keep going, Aaron.
Just a quick call out to Daily Push. I can keep going for 15. The last question that Daily Push came out with was, is your Lambda doing any data manipulation? In this example, no. So the Lambda here is really querying. So this, in terms of CQRS, so query and CQRS. Am I saying that right? Command, query, segregation. Yes. So command would be your mutations, and then querying. So this Lambda is purely the query and not the mutation. I do have another Lambda that I use for writing to the database, but in terms of ETL, so actually querying, manipulating data and sending it back, this one's not, but it can be. So you can use Lambda to do a little ETL, do some query. And as I said, if you're querying multiple data sources, that very much might be where you are querying one, like an index, to get the parameters that you need to query of another, and then you query another, like a relational database, to get that data. And then based on the data, you might transform it and then send it, as the result back. But then also, that's just working within the Lambda itself. Remember, in Appsync, you also have the response and the request and response maps. So you could actually have the response resolver have the data directly from the Lambda, and then do the mapping of that data in the response resolver for the Appsync itself. So it's really up to where you want to manage the actual translation or the mapping of the data, whether it's in the Lambda and you just handle the querying and hand it off to Appsync, and then let the actual response map resolver do it, or do it all in your Lambda. It's really up to the developer who's doing the solution.
Yeah, nice. The other thing is, you don't have to really worry about the resolvers when you get started, right? So like when you want to use Appsync, like the main thing that you do when you're creating a new Appsync endpoint is you define your schema. And so in that schema, like you can have it tied back to DynamoDB pretty seamlessly. For example, as like a primary data source, and you can start to build out your application like very, very simply. But like when you're working in a complex organization, like what Aaron's showing, like is exactly what you'd want to do, right? Because you're going to have things sitting in RDS. You might have some Aurora instances. You might want Elasticache brought in. You might want Redshift. I've seen a couple of times brought in with Appsync. Like you can basically write resolvers for any connection that you want, and then kind of like in those resolvers handle the logic and like how that interaction works with that data source, and have it come back to end users. The thing that I like what you've done here as well, like I know that we want really discrete things when it comes to Lambdas, right? Like you don't write a Lambda that's going to do 20 things. Like you've got this query Lambda, and then you've got like your mutation, like your update, delete, create Lambda that you've got, maybe separate Lambdas in those cases as well. But the nice thing about that is you can actually point to your database read replicas. So every time that you're going to read data, you're going to call this resolver. this resolver is using like a read-only Lambda. That Lambda is hitting always the read replicas of your database. So it's always leaving the performance for things that are going to be write intensive within your application too. So like, I really like how you've done that there, Aaron, as well.
So that I'm a big supporter of using the right patterns for the right solution. So in this case, CQRS is the right pattern. Obviously, the separation of the query from end, so the mutations from the queries. Appsync inherently does that for you. So when you're using Amplify and you generate your client-side code, it segregates the actual queries from the mutations into separate code files. So you are doing that a little anyway. But in the backend, so I'm an integration specialist. So I'm a big proponent of, or a big supporter of domain-driven design and working with the right patterns. And in this case, when it comes to integrating between multiple components, you're spot on. Like even if it wasn't CQRS and it was something that has many functions, working within domain-driven design, like breaking down your lambdas into smaller domains, so functions that facilitate, very similar to a microservice environment. Like I don't want to go so far as to say microservice, but you'd be working with containers, serverless, whatever it is, and breaking them down into micro components that facilitate a specific domain. And then you actually help your developers by, if something goes wrong with one of those small domains, you don't need to pull everything down to fix it. You basically fix that one component while you can secure and work with every other component that's up and running. So again, that goes to the back to the micro front end discussion before around the front end way of doing things. It helps the actual development teams break out into separate teams and work more seamlessly on managing specific domain requirements.
Nice. No, that's very cool. By the way, my app built a while ago, so I can quickly show that.
Let's have a look.
Something else that you want to point out here?
No, I'm keen to see it.
Okay, cool. I will get my screen share happening then. Give me 2 seconds. So this is it. So you can see I've got this Amplify provided URL. I could add a custom domain, as I mentioned beforehand, just in case people weren't in the stream. But what I was doing was I was testing out Next.js in case anyone's just coming quite new. So Aaron wanted to show Appsync, and then that's because I thought Appsync's kind of relevant from when I want to move out my location.json. I could have broken into a Lambda, which is what I did when it comes to what I'm building in my Next.js app. But I could have taken the Appsync GraphQL approach as well, which I think is actually probably better long-term as well. But like this application here, so it's Next.js. This is a server-side rendered / client-side rendered / static site generation framework. And so you can kind of like render things where you want, and they call that hybrid rendering in that picture. But this site is, these endpoints that I've got, like for each of these locations that I visited, like now they are talking to a Lambda, and I'll show you that code in a second. But if I click into each of these, it actually adds like a query string on the end of my URL. And so it knows which location to bring up, like Coffee Mountain. So this is all kind of like now hosted in AWS land, and most of the site's server-side rendering. But like there's a little bit that's happening on the client side as well. If I go to my web developer tools, I'll bring those up. The other thing that you can see is actually, no, what I want to do is I want to view page source. Like this is probably not going to be too readable looking at it. But like what you can actually see, and I'll scroll halfway down, is you can see like it's all HTML that's getting returned. So this isn't JavaScript, even though our app's written in JavaScript. Like what it's doing is it's rendering the static HTML for us, right? And then you've kind of got like these like dynamic page links that go to different locations of my application. But at the end of the day, like this is, even though it's written in JavaScript, it's all getting produced on the server side as HTML. And the cool thing about like Next is it uses these placeholders to basically know where things are up to as well. So like, let me see if I can find one. But like it puts in these little next flags to tell you what position it's at. And the cool thing about that is like next data. So like what happens here is if I had like 5 locations pre-rendered on the server, but I had a long list of locations, like I had 20 locations in the end, I could actually dynamically have those fetched from the client side rather than the server side. So if I wanted to have like this list, I could scroll down and have it dynamically loaded. The initial sites generated HTML and rendered server side and passed to the client. But then everything else is then done through JavaScript on the client side and rendered dynamically over there. So that's kind of one of the benefits of like Next.js. It's one of the unique elements of it. I wish I could have like viewed that a little bit better in terms of source. And I think if I do like a reload of the site as well, you can see, like it is loading some JavaScript in the browser, but the majority of stuff is coming through as server-side rendered. The image takes a little bit to load as well. One of the cool things that Amplify does is it like breaks out the hosting into S3 for a lot of the web assets, and things that need to like specifically call a function are going to be created as like lambdas hidden in the back end. So yeah, this is the site. And what I might do is I'll quickly show my code.
That's really cool just from the point of view of if you can pre-render the first query. So if you've got a large data set, you don't want to wait for the whole data to query to render out. You just query the first page of the data, and then the rest of it's through client side. That's amazing, because that goes back to the original question that I had around, have you seen the difference in the side versus client side? But with that hybrid approach, bang, you've rendered the first page of data, so it's there in your pre-render, but then you can query the next page, for every page that you need to view. I love it.
Yeah, no, it's pretty nice. And so like to get the location data, I moved away from that like JSON file that I've got in my public folder. And I created that like Lambda using the Amplify CLI, which built like some CloudFormation, like created the resources in my AWS account. I have my region set to Southeast 2 when it comes to the CLI. So that's why everything's created there. But this Lambda, I basically, like whilst Aaron was going, I just did like a wait fetch, called that endpoint, put the query string on the end, like for the coffee, and then basically like the results returned as JSON. And then I basically set that as an object of my props. So that once the page is rendered, like after they get initial props, the page is rendered, like I've got all that data that I can use across each of my different views. And as I mentioned beforehand, I could like move away altogether from that Lambda code, which was basically just if I go into it, it's basically just like rendering that same JSON object that I've minified. I could then dynamically start to work on this particular Lambda code in particular and tie in a data source, similar to what Aaron showed with Appsync, right? So I could take that direction with how I build this out as well, which is kind of why we've jumped topics between Amplify and Appsync, but I think they play very nicely together, and what Aaron had kind of complemented what I'm starting to work on in my little experiment that I've got here. If you want to give it a test, I mean, it's not the most exciting site in the world as well. We do have a URL, so I'll just stick that in the chat here. And if you want to see the little project that I've created, I will bring that up for everyone as well. So I'll just share the GitHub across too, because I've stored everything in there. So if you want to take a look-see, feel free to take a notice. But those are the two assets that if you did want to kind of like follow along and see what I've done, you can do so here. And I'll probably develop it in the coming weeks as well and build a couple more functionalities before I put it away, because I want to do some Python stuff in the next couple of weeks and IoT type projects. So yeah, usually I have something in the background. This is my particular hobby at this point in time.
Awesome.
Excellent. Now I know we've gone over. Is there anything else that you wanted to show, Aaron, on your side? Anything that you'd wanted to point out on the Appsync front?
No, I think I've thrown a lot at them today, so I'm very happy to come back and talk more later. But I think I'll leave it at that for now. Maybe when I get the GraphQL query engine in Lambda working, like as in instead of having to do table-based querying, I'll come back and demo that.
Yeah, that would be really cool. And I know you've also built a chatbot that I was thinking we'll have to show off one week. We did do chatbots last week. We had a look at like
Last week, yeah.
tying in Amazon Lex, but I definitely want to have a dive into what you've done as well. So we'll have you come back in a couple of weeks again.
That would work well because that actually, it is Lex, but it's also using like Kendra, like I said before. It is using Appsync to facilitate different data sources, but it's actually a chatbot as a service. It's a single embeddable chatbot that works to a single chatbot engine with a context engine, which actually helps to facilitate more conversational AI as opposed to more your question and response standard workflow does. So very happy to demo that.
Daily Push has said the unpredictable chatbots. I spent 5 of my years developing chatbots, and my whole job in that 5 years was effectively trying to make sure that they would escalate appropriately versus be unpredictable and just like spit out garbage, right? So there's good paths where you can escalate to like live agents if you're in a business and you've got like support operators. But you can also evaluate like what the accuracy and sentiment of the response is before you send it out. Like what was the sentiment of what the user wrote last, and what was the accuracy of what you're just about to respond with, and you can make those calls versus sending it straight away across, and that kind of can enhance the experience as well for end users too, because you don't want it to send the wrong response, right? You'd rather it go a bit more generic than highly accurate and something that's completely inaccurate.
So that's exactly to Daily Push's point as well, mapping to intents. That's where the conversational AI that we're building extends Lex, so that it's not mapping utterances to intents. There are a few pre-designed utterances and intents, but most of it is managed through a designed context engine. So it's actually utilizing things like Neptune database to develop a graph. So I'm talking about a data graph here, which is different to GraphQL, of relationships between data and context and questions that the customer is asking. This is all AI ML backed conversation, as opposed to, as you said, an intent and an utterance. And that's very much question and answer, which is, you can tell you're talking to a bot, and then you sometimes get the weird response. But the idea is here, the more that we get into the AI ML side of things and the context engine, understanding the context of the question being asked and the fulfilling data sources, the more we get into conversational AI that is more like talking to a real person. And then my aim with this project is, obviously we do actually have a live connect, so you can talk to a live agent, but the aim is that you can move seamlessly between AI and live agent, and you won't know the difference. The customer won't know the difference because they're talking about something that the bot can facilitate, but as soon as it gets to a domain that the bot can't know, it seamlessly hands it off to a live chat agent who takes over, who chats, and then goes, cool, we've done the conversation between the live chat, and hands it back to the bot without the customer knowing. So that's where conversational AI is evolving in more than just the standard query and response chatbot style.
Yeah, exactly. And one of the other things that I find fascinating is, some people say that chatbots is like talking to a terminal. I used to get that feedback all the time. So it's like, why don't we go back to terminal days? When people want to, poke at chatbots, that's fine, good and all. But, one of the things that I think will evolve as well in the space is, like actual conversational in terms of like speech, right? Like tying to, Poly, Alexa type experiences in the long run as well. Like, because, we don't want to sit and look at screens all day, unless you're myself and Aaron, which we love. But the other side of the equation as well is, like how do you leverage the dynamicism of a chatbot where it can give you a response straight away to do with something to do like with your question, versus having to navigate like 5 pages in a website to find the information. And that's kind of where I think the industry is going to go as well, is this whole dynamic prediction of like what's relevant to you and what you want, and then work out the rendering.
If I can give a shout out, like exactly what you were saying there is there are some niche agencies in Australia at the moment who are actually focusing specifically on exactly that. Like, if you don't mind, I want to shout out Versa agency. Versa have gone from a marketing web agency to now a conversational AI specialist, and they're doing exactly that. Their own website, go and check out the Versa website. Let's see if I can remember it. If it's versa.com, go and check it out, because their entire website, I'll just see if it's not versa.com. It's versa.com.au probably. Their entire website, it's not it's not that one as well. Let me, Versa Agency, that's why. Go and check out their website. Their entire website is actually built out. So it's versa.agency. I'll just chuck it up on the private chat. Their entire website is actually built as a conversational AI. So they've moved away from the traditional, menu, and you select the category that you want to go to. But these guys actually specialize in integrating with Amazon Connect and doing the seamless handover of chatbot to live agent and doing projects like that. Like, to what Matt was saying, it's not gonna be just us working on a command line or us working on a terminal talking to a chatbot. Like, conversational AI, like with Alexa, is becoming the latest range of Alexa. You now have video, so you can do images, video, sound, like you're talking to Alexa, yes, but now you can see and interact with, pressing buttons on the screen. Conversational AI is more than just text, and the industry, especially these small agencies like Versa, are pushing this technology and pushing the industry in conversational AI leaps and bounds forward for interaction. Like, the way that brands interact with their customers and vice versa is so much different to how it was like 5 years ago, with the website having a little chat bot to find something on the, I'm stuck, I can't find something, help me, and then handing off to a live chat agent saying, oh, well, it's on this page, go there. Like, actually the chat bot or the conversational AI is the focus of the interaction, and the information is secondary, as opposed to, the traditional way. So it's just amazing what is capable at the moment, and where we're going with conversational AI and interaction itself.
Yeah, and technology as well. Like, how's that going to change? Like, I know that the web's been wanting to do 3D for a long time, but we've got like AR and VR type experiences, and new products that will come out to the market in the next couple of years. So yeah, I think anyone that's in web development or mobile app development is in for a ride over the next couple of years. I'm pretty excited to see, what the end user experience is like when it comes to the web and to mobile applications. And so, we're both passionate about Amplify and Appsync, as you can see, and front ends in particular.
And chatbots.
Yeah, chatbots, like all the things, right? But that's kind of why we have the show, right? Like, we want to have a little bit of an ad hoc session most of the time. We want to kind of get together, share our thoughts, show off some of the projects that we've got in the works. We like to show cool IoT based projects as well. And so, I'd just like to say thanks for joining us this week. Thanks, Aaron, for coming on. It's always great to have you, and I'm sure you'll be on and off in the future. And you definitely need to come and talk about the chatbot that you've built, because you've spent like years on it. And it's like a pretty complex beast, right? But it's pretty awesome, and it's going to be used in a number of like real life space places in the future, which is going to be really, really cool as well. So yeah, with that being said,
thanks for all the questions as well. Like, there's been some really great audience questions that really makes it fun.
Yeah, the audience is always great, and there's always like a base of people that watch us every single week. Lunchtime's a Wednesday in Australia, so 12 p.m. AEST time. Really grateful for everyone that kind of like makes the effort to come in and hears our rambles sometimes, but like helps us build cool projects. You guys make it really, really fun, and I love seeing newcomers as well come into the chat. You guys are great as well, and hopefully you enjoy the content in the show, and hopefully it's a little less formal than most of the training videos that you'd watch. We try and keep it that way, but also know it doesn't work for some people. Give us ideas on what you'd like in terms of like content for the show. We have a really cool API gateway type security solution that we've got in a couple of weeks that we're showing off. There's some Redshift things in the works for people that want to dive into that area. Next week we have an IoT specialist from New York. She's coming in and she's showing like this IoT project that she's built as well. 11 p.m. in Houston. It's late you guys' time. That's awesome. 11 p.m. EST. Yeah, there we go. So, yeah, come join us next week. It's going to be a session on IoT, same time. And yeah, enjoy your evenings, afternoons, mornings, whatever it is in your particular time zone. Thanks, everyone.